Hi everyone, hope you're all okay. Today's double lesson, you've got to find out what a stationary wave is. Okay, so I'm going to give you a bit of an introduction, but I've also put up links to other videos. I'll put a few links to videos that I've done where I'm trying to demonstrate this to you. And I'll put the references from the textbook as well. Okay, so we're doing about stationary waves. Make sure you spell stationary correctly. They're also known as standing waves. Okay, so if I say standing waves, I mean stationary waves. That's the term used in our syllabus. So far we've looked at progressive waves, and as hopefully you know, progressive waves take energy from one point to another point. Okay, and the speed that they go depends on the medium they travel through, and then we've got frequency and the wavelength are dependent on the energy put in, that sort of stuff. Now, stationary waves are formed when you've got a wave that would have been travelling, but it reflects back and it interferes with itself. So hopefully you know what superposition means and can define it. If you can't, make sure you learn it. It is that the displacement of a point is the sum of the displacements of the waves that meet at that point. So what happens with a stationary wave is wave would reflect at some point and go back and interfere with itself. Now what you get is you get a pattern that looks like that. Okay, so what's happening at these points is nothing. These points are not moving, and these points are called nodes. What's happening at these points though is you've got rapid movements, and these are called antinodes, as whatever it is that the wave's travelling through is going from one place to another place really quickly and backwards. Let me try and demonstrate this. What I've got here is I've got a spring that I've anchored at one end. Okay, so if I pull the spring across and if I just wobble it slowly, can you see I've got sort of pattern where the bit that's moving most is the middle bit. I'll just move my fabulous stand there. Now, if I move it with a faster frequency, can you see I get a different pattern where the middle point doesn't move and I've got 2 points with maximum movement and in between points with in between movement. Okay, so that's what's known as a stationary wave. And what was happening there as the energy was going along the spring to when it got to the end of the spring, and it reflected back, and we got this pattern here. Now, stationary waves, they have some similar bits to progressive waves. They've got a wavelength. They've got a frequency. They don't really have a speed because they don't travel anywhere, and they don't take energy from one place to another place. They store energy. So there are some differences, and you can read through your book all about them. Now, when you get a stationary wave, you can work out the wavelength, and hopefully you'll have done this in GCSE, and hopefully you'll have seen an experiment where you get a vibration generator going up and down and transmitting waves along a bit of rubber piping or a string, and you can see the pattern of it. And so you'd have a vibration generator, which is just something that moves up and down, up and down. What you'd have then is you'd probably have a triangle made of wood or something, and you'd have a bit of string, I can't draw it seems, going along over there, and you'd put some tension on the string there. Okay, so that string should be resting on top of that triangle, and then what happens is you increase the frequency, and at a particular frequency you get a pattern like this. So you've got a node at the end, and then you have a big antinode in the middle, node at that end. Then what happens is you increase the frequency even more, and you get a pattern that looks like that. Okay, with a node there, a node there, a node there, antinode there, antinode there. Now, the distance between two nodes, that distance there would be half a wavelength. Can you see why in this example? Because a whole wavelength would be from there to there. So the distance between two nodes is half a wavelength. Okay, so you're going to watch the videos that I put up. Some of them aren't that quality. I've got the microwave one wrong and I can't redo it because I haven't got any more chocolate. You're going to have a look at some examples of this, and I'll link all the other videos. You've got a worksheet to go through, and you can email me any questions, okay? So yeah, have fun, keep in touch, and hopefully I'll see you all soon.